My name is Alvin Clint Mararak. For our presentation, we're going to discuss the photovoltaic system. Let us first define what is the solar power. It is the energy from the sun that is converted into thermal or electrical energy. Solar energy is the cleanest and most abundant renewable energy source available. So, yung solar energy, natawag siyang cleanest or most abundant dahil sa hindi siya nagre-release ng greenhouse gas. And most abundant naman dahil pwede natin siya masasabing infinite dahil yung nilalabas na energy ng araw ay marami talaga or plenty of supply. So, paano ba mako-convert yung solar power into electrical energy? Dito papasok yung solar technologies. In solar technologies, it can harness the energy for a variety of use, including generating electricity, providing a light or comfortable interior environment, and heating water for domestic, commercial, or industrial use. So, yung solar technology is yung nagiging instrument para ma-convert yung solar power into electrical energy. So, yung karaniwan na solar technology na ginagamit is yung photovoltaic solar technology and solar thermal technology. Yung photovoltaic technology is it will directly convert the sunlight into electricity, while the solar thermal technology will capture the heat of the sun. Para mas maintindihan natin what is photovoltaic technology, here is the illustration. So, yung sun tatama sa solar panel and then magkakaroon na ng electricity. While the solar thermal technology naman is tatama sa mga mirrors yung sun and then magre-reflect sa tube na naglalaman ng fluid, which is siya yung magiging magbo-boil sa water and then turning into steam, and then yung steam yung magpapaikot sa turbines, and then ayun na, didistribute na yung electricity. So, ano ba yung solar power plant? A solar power plant is any type of facility that converts sunlight either directly like photovoltaics or indirectly like solar thermal plants into electricity. So, yung solar power plant is katulad nito. This is a solar PV power plant. And then ito naman is solar thermal power plant. So, there are two main types of solar power plant, which is yung photovoltaic power plant and then solar thermal system. Yung photovoltaic power plant, this type uses the energy from the sun and converts it into electricity using a solar cell. Then solar thermal system naman is solar thermal power plants utilize energy from the sun to heat a fluid to a high temperature. This fluid then transfers its heat to water, which then becomes superheated steam. The pressure from the steam causes the turbine to turn. So, the largest solar farm in the world is located in India with a total capacity of 2.25 gigawatts across 14,000 acres or approximately 5,700 hectares. Badla Solar Park in India is the largest solar farm in the world to date as of 2021. Located in the village of Badla in the Jodhpur district of Rajasthan. So this project is the #1 solar farm in the world in terms of capacity. So this is the aerial view of Badla Solar Park. Solar power plant in the Philippines. The Alatagan Solar Farm is a 63.3 megawatt solar power plant in Calatagan, Batangas, owned by Solar Philippines. It was reported that the groundbreaking for the solar facility was done as early as March 2015. Solar Philippines, a local company, developed the project, which cost 5.7 billion pesos. The facility was built by 2,500 people in 160 hectares or 400 acres land near the foot of Mount San Piro. Upon its completion, the solar farm has 200,000 panels. So majority of the funds for the project's cost was shouldered by the Philippine Business Bank, Banco de Oro, and China Bank, and the Bank of Commerce also provide funds. By the end of February, the Calatagan Solar Farm is already generating power weeks before the deadline set by the Department of Energy of March 15, 2016. This is the view of solar farm, Calatagan Solar Farm in the Philippines. So what is the here is the solar module, solar system, and solar cell. Sa solar plant, it consists of solar panels. Yung solar panels ay consist ng solar cell. So, paano bang gumagana yung solar cell? Paano siya nag-generate ng electricity pagka tinamaan siya ng sunlight? The answer is, the main thing that is happening inside the solar cell or photovoltaic cell is photovoltaic effect. The photovoltaic effect is the generation of voltage and electric current in a material upon exposure to light. It is a physical and chemical phenomenon. The photovoltaic effect was first discovered in 1839 by Edmond Becquerel. When doing experiments involving wet cells, he noted that the voltage of the cell increases when its silver plates were exposed to sunlight. So yung solar cell, siya yung dahilan kung bakit nagge-generate ng electricity pagka naarawan. So yung process naman na nangyayari sa loob ng solar cell is what we call the photovoltaic effect. So to achieve the photovoltaic effect, we need a material which, when struck by sunlight, will exhibit some characteristics of conductor. So the question is, what is happening inside a copper conductor when there is no presence of voltage across it? So the answer is, its valence electron is free to move, transferring from one atom to another in random.
How do solar cells work? That particular characteristic of a conductor where there are numbers of electrons that moves freely, what should be attained to exhibit the photovoltaic effect? So, ano daw yung kailangan ma-attain para ma-achieve yung photovoltaic effects? So, dito na papasok yung silicon semiconductors. The silicon semiconductor absorbs energy from the sun. So, yung silicon semiconductor daw is na-absorb niya yung energy from the sun. The protons which the sunlight have could knock an electron out of its orbit within an atom. So, yung protons na galing sa sunlight is nananak niya yung electron out of its orbit within an atom, making it free to move within the system in random. So, yung nanak na electron, mag-move siya in random within the system. Yes. Lattice structure, silicon atom forming a covalent bond with 4 neighboring atoms. So, ito yung silicon atom natin forming a covalent bond with its kapwa silicon yan na. How do solar cell work? Another thing that is needed to achieve by the silicon semiconductors for it to exhibit the characteristic of a battery where there is an imbalance of charge on both sides. So, ito daw yung another thing na kailangan ma-achieve ng silicon semiconductor for it to exhibit of a battery where there is an imbalance charge on both sides. So, kailangan daw imbalance yung charge ng both sides. Therefore, two sides should be created, the so-called PN junction, making the two sides of the junction positively charged and negatively charged. Pure silicon is not enough to achieve this. This is achieved through doping. Doping is the addition of the substance in a semiconductor for the purpose of modifying its electrical conductivity. So, yung doping daw is addition ng other substance. Kunyari, mag-add ka sa silicon ng boron, phosphorus, para ma-modify yung electrical conductivity nito. So, ano yun? Doping. Doping is the addition of the other substance in a semiconductor. Purpose known is to modify its electrical conductivity. The silicon should be doped with atoms which contain more valence electron to create negatively charged silicon, or with atoms which contain less valence electrons to create positively charged silicon. So, sabi dito, silicon should be doped with atoms which contains more valence electron to create negative charge silicon. So, sabi dito, yung silicon daw is kailangan makipag-dope sa isang atom na may or mas maraming valence electrons sa kanya para makabuo sila ng negative charge silicon, or with atoms contain less valence electrons to create positively charged. So, negative naman yung kailangan, negative or mas lamang yung silicon kaysa sa idadagdag mo panibagong or sa pagpo-form niya ng covalent bond is mas mababa yung valence electron para mag-create siya ng positively charged silicon. So, ito yung periodic table of elements. How do solar cell work? On the N-type sites, phosphorus is being used as the doping material, while the P-type is boron. So, lattice structure of silicon with phosphorus as dopants. So, ito yung N-type material natin. Mapapansin natin dito yung silicon is nakipag-dope siya sa phosphorus. So, anong mangyayari sa phosphorus? Dahil nga, lamang siya sa valence electrons. So, may matitira siyang electrons na walang kadugtong. Same lang sila. Ito naman yung lattice structure of silicon with boron as dopant. Dito naman, yung silicon, nag-dope sila ng boron. So, yung boron nga is mas kulang siya sa electron or mas kulang siya sa valence electron, which is nagpo-form ng hole. So, ito yung natin, P-type natin, yung silicon with boron as dopants. So, ito na yung PN junction natin. Yung nasa taas is the N-type material, which is the silicon with phosphorus as dopants. So, yung taas na ito is silicon na nakipag-dope sa phosphorus. Then sa baba naman is yung silicon with boron or silicon forming a dope with boron. Silicon yung boron. Tapos yung gitna nito, depletion region. Ang mangyayari kasi dyan, guys, or next muna natin to, since there is the rush of electron from the N side towards the P side, the charge of the two sides will be reversed, making the boron dope P side become slightly negative and the phosphorus dope N side slightly positive. So, ito nga mangyayari dahil nga yung N-type natin, yung N-side natin, or yung upper side natin, dahil nga there is the rush of electron from the N side towards the P. So, dahil nga may hole sa baba or sa P side natin is may hole, then sa taas naman or sa N side natin is may sobrang electrons. So, ang mangyayari, yung sobrang electrons na yon is magra-rush siya doon papunta doon sa hole. The charge of two sides will be reversed, making the boron dope P side become slightly negative and the phosphorus dope N side slightly positive. So, pag nangyari daw yun, ang magiging charge daw nung N side natin is positive, then yung magiging charge naman nung P-type natin is slightly negative. So, ito nga. So, ang nangyari sa n-side natin, which is yung nasa taas, is naging slightly positive. Then yung nasa p-side natin is naging slightly negative. And,
So, good day everyone. So, my name is Joshua F. Di Fiesta. So, I continue discussions the photovoltaic system. So, how do solar work? So, the amount of sunlight that strike the Earth's surface into our a half is enough to handle the entire world's energy consumptions for a full year. So, solar technologies convert sunlight into electrical energy either through photovoltaic panels or through mirrors that concentrate solar radiation. So, the energy can be used to generate electricity or be stored in batteries or thermal storage. And the photovoltaic basics. So, when the sun shine onto a solar panel, energy from the sunlight is absorbed by the photovoltaic cells. So, in the panel. So, this energy created electrical charge that move in response to an internal electrical field in the cell, causing electricity to flow. So the rush of electrons will quickly from a barrier between the two sides called deflections region. In here equilibrium is being reached. Then electrons stop flowing. So an electric field is definitely created. The silicon junction is now exhibiting a characteristic of a battery. So these p-n junctions. So how do solar cells work? Again, so the sunlight enters the n-type side when penetrates the deflection regions. This process knocks an electrons out of the band as many as it can, creating a pair of free electrons. So in holes in the deflection region, so the electric field drives the pair out of the deflection region. So the free electrons goes into the n-type side and hole in the p-type side, so resulting in higher concentration of both. So the deflection regions heavily doped. So when heavily doped in n-type semiconductor is joined with the heavily doped p-type semiconductor, so a p-n junction is formed. So in n-type semiconductor, large number of free electron is present. So due to this, they get repelled from each other and try to move from higher concentration region n side to a lower concentration region, so p side. So similarly, in p-type semiconductor, holes get repelled from each other and try to move from higher concentration p side, so region, to a lower concentration region, so n side. So the free electrons that cross the junction provide extra electrons to the atoms at p side by filling the holes. So the atoms which gains extra electrons at the p side become a negative ion. So similarly, the free electrons which left parent atoms to fill the holes at p side create a positive ion at n side. So depletion regions are lightly doped. So the free electrons in the n-type semiconductor experience a repulsive force from each other and try to move uh, from a higher concentrations region, so n side, to a lower concentrations region, p side. Similarly, the hosts try to move from a higher concentrations regions, p side, to a lower concentrations region, n side. So in the lightly doped semiconductors, their recombinations rate is very slow. So hence the free electrons from n side across the junctions and fill the holes in the atoms at p side before they recombine with the positive ions at n side. So the parts of solar panels. So aluminum frame, tempered glass, solar cells, encapsulant or EVA, so backsheets and junction box. For the solar cells, solar photovoltaic cells or PV cells convert sunlight directly into DC electrical energy. So the performance of the solar panels is determined by the cell type of characteristic of the silicon used. So will the two main type being mono crystalline and polycrystalline silicon. So the base of the PV cell is a very thin wafer, typically 0.1 mm, so thick, and is made from either positive p-type silicon or negative n-type silicon. And the glass or tempered glass, the front glass sheet protect the PV cells from the weather and impact from hail or airborne debris. The glass is typically high strength tempered glass, which is 3.0 to 4.0 mm thick, and is designed to resist mechanical loads and extreme temperature change. Next is aluminum frame. So the aluminum frame plays are critical roles by both protecting the edge of the laminate sections housing the cell and providing a solid structure of mount and the solar panels in position. So the extrude aluminum sections are designed to be extremely lightweight, stiff, and able to withstand extreme stress and loading from high wind and external force. And then the EVA film or EVA film stand for a ethylene, a vinylene acetate, which is a specially designed polymer, higher transparent. So layer used to encapsulate the cells and hold them in positions during manufactures. So the EVA materials must be extremely durable and tolerant of extreme temperature and humidity. It plays an important part in the long-term performance by preventing moisture and dirt ingress. And last is the backsheet. The backsheet is the nearmost layer of common solar panels, which acts as a moisture barriers and final external skin, so they provide both mechanical protections and electrical installations. So the backsheet materials is made of various polymers or plastic, including PP and PET and PBF, so which offer the different levels of protections, thermal stability, and long-term UV resistance. So the backsheet layer is typically with typically white in color, but it's also available with clear or black depending on the manufacturers and module. So next is, ito pala yung last, yung junction box. So the junction box is a small weatherproof enclosures located on the rear side of the panel. So it is needed to securely attach the cables required to interconnect the panels. So the junction box is important as it is the central point where all the cell set interconnect and must be protected from moisture and dirt. So how do solar cell work? So just to answer these questions, let's first study the component of a solar cell. So yun nga yung mga glass interactions, interreflections, hosting, material grid, N-type, P-type, silicon, and metal plate. So how do photovoltaic power plant work? So solar photovoltaic power plant work in the same manners as smaller domestic scale PV panels. So as we have seen, most solar PV panels are made from semiconductor materials, usually from some from a silicon. When the photons from sunlight hit the semiconductor materials, free electrons are generated, which can then flow through the materials to produce a direct electrical current. So step-up transforms are required to boost the 480 to 690 volts inverter's output voltage to the 13.8 uh, kilovolts and to 46 kilovolts of the medium voltage utility network. So it is then connected to substations for distributions into residential area. So when installed at site, solar modules are wired together in series to form a string. So string of modules are connected in a panel when necessary to form an array. So in a traditional PV plant's single centralized inverter provides the voltage inversions. So yan yung diagram ng how to photovoltaic power plant work. For the sunlight, the solar modules, the mountain rocks, dadaan siya sa transfers DC electric to inverter. So papasok siya sa inverter, then lalabas, dadaanan niya ulit yung the transfer and converter AC electricity. So pasok sa AC service panel, then the AC utility net meter, then pupunta siya sa IBMI voltage setup, then utility grind. So i-contribution na siya sa mga nangangailangan ng kuryente. So that's all. Thank you.
Continuation of our discussion about the two types of solar power plant. Previously, we discussed about the photovoltaic system, and now we're going to discuss the solar thermal system. So the operating principle of solar thermal system. The solar thermal system, or also called CSP, its operating principle is the solar thermal power plants collects the energy from the sun with the use of mirrors. The collected energy is being reflected or redirected to a tube. This causes the fluid to achieve high temperature. The fluid then transfers its heat to water, which becomes superheated steam. This steam is then used to turn turbines in a power plant, and this mechanical energy is converted into electricity by a generator. So, ganun nag-ooperate yung solar thermal systems. Gumagamit sila ng mirrors para kolektahin yung energy from the sun, and then magre-reflect yon sa tube, and then yung tube na napag-replica ng mirror is may lamang fluid. And then pag uminit yung fluid, ito yung magpapainit sa water. And then yung water naman is mag-turn into steam. And then yung steam, ito yung magpapaikot sa turbines. And then yung mechanical energy na na-produce ng turbine is makakonvert to electricity using the generator. So there are four types of solar thermal systems: the parabolic trough, solar tower, linear Fresnel reflector, and parabolic dish. So these types of thermal system operate in the same principle. So nagkakaiba lang sila sa pagkuha ng paraan ng pagkuha ng sunlight. Pero kung paano nako-convert yung sunlight into electricity is pare-parehas lang sila. So, ano nga ba yung parabolic throw? Parabolic throw's general description. These throws are also known as the line focus collectors are lined up in a row on a solar field and are composed of a long parabolic shaped reflector that concentrates incident sunlight on a pipe that runs down at the middle of the throw. The collectors utilize a single axis solar tracking system to track the sun across the sky as it moves from the east to west to ensure that there is always maximum solar energy incidence on the mirrors. The receiver pipe in the center can reach temperature upward of 400 degrees centigrade as the throw focuses sun at 30 to 100 times its normal intensity. So yung parabolic throw, parabolic shape mirror siya na nagro-rotate from east to west. And then mayroon siyang solar tracking system para matrack yung sun kung saan man siya nakapwesto. And then yung pipe naman na nasa center ng parabolic throw is kaya niyang mag-reach ng temperature hanggang 400 degrees centigrade. So, para mas ma-imagine natin kung ano yung itsura ng parabolic throw, ito siya. So, makikita natin na naka-parabolic shape yung mirrors. And then, pag tumama yung sunlight dun sa mirrors, tatama siya sa pipe. So, here is another picture of how parabolic throw operate. So, as the sunlight hit the mirror, it will reflect through the tubes. And the tube is covered with glass. Kasi may characteristic yung glass na nagpe-penetrate yung sun pero natatrap niya to. Pag nakapasok na yung sunlight sa loob is kaya niyang itrap, which is mas magpapainit doon sa fluid sa loob. So here is the parabolic throw basic diagram. So makikita natin dito yung cycle. So ito, yung cycle ng parabolic throw is nagsisimula sa cold salt tank. Yung cold salt tank contains solar molten salt. And then it will travel through the solar collectors. And pag mainit na yon, pag uminit na, is magpo-flow siya through hot salt tank kung saan doon siya maiimbak. And pag kailangan na ng kuryente, yung high temperature molten solar salt is magpo-flow sa heat exchanger. Simultaneously, yung water from water storage tank and then yung high temperature solar molten salt will hit the water, creating a superheated steam. And then yung high temperature solar molten salt na nagpainit sa tubig is lalabas siyang malamig na. And then babalik lang yon sa cold salt tank kung saan siya nagsimula. Then yung steam na galing sa heat exchanger is magpo-flow sa turbine, which will generate the electricity. From the turbine, the steam condenses back into water and return to the water storage tank. So what is happening inside the heat exchanger? So the molten solar salt, which is hotter before, will enter and then exit cooler. And then yung water naman, which is enters cooler and then exit hotter. The fluid that enters the tube side will flow in the tube. That's why it's called the tube side. while the shell side, the fluid that enters the shell side will flow inside the shell. The actual view of shell and tube heat exchanger and steam turbines.
Oh, parabolic truth operating principle. Heat from the sun is being collected by special mirrors, which is then reflected to the pipe that runs down the middle of the truth. So, heat from the sun is being collected by special mirrors. So, then reflect it to the pipe na merong HTF sa gitna. So, it collects energy from the sun using mirror. Within this central pipe is a heat transfer fluid. So, yun nga, merong, so within dun sa central pipe or sa tube is merong siyang heat transfer fluid na flowing inside it. So, na umaagos sa gitna nun. So, the heat transfer fluid inside the pipe can reach a temperature around 400 degrees Celsius as through focusing sun at 30 to 100 times its normal intensity. So, yung heat transfer fluid sa loob ng pipe na yon is kayang mag-reach ng 400 degrees Celsius. Because of the sun focusing at 30 to 100 times its normal intensity. This hot fluid goes to heat exchangers where the heat is transferred to water, generating high pressure superheated steam. So, yung HTF na to or hot fluid pupunta siya sa heat exchanger. Then, doon sa heat exchanger, ita-transfer niya yung heat niya sa tubig, generating high pressure superheated steam. This steam then moves a turbine power generator and produces electricity. So, yung steam na yon pupunta naman siya dun sa turbine power. So, yung turbine power na yon isa yung generator para mag-produce ng electricity. The HTF then keeps circulating within the system. The steam is being condensed which is to be sent back through the heat exchanger. So, pagtapos mag-steam yung tubig, then papasok naman siya ulit sa condenser. So, wherein the hot steam will be convert or being condensed to water again. So, doon, magiging water ulit siya, then ganun, paulit-ulit lang. So, magpupunta ulit siya sa heat exchanger. Heat transfer fluid. In a solar thermal system, heat transfer fluid, HTF, is a liquid or gas specifically manufactured for purpose of transmitting heat from one system to another. So, yung heat transfer fluid is purposely for transmitting heat from one system to another. So, heat transfer fluid. Why use HTF of the direct system in which water is instantly turned into steam by the heat reflected by mirrors in solar thermal system or concentrated solar power? So, sabi dito, bakit daw gagamit pa ng heat transfer fluid kung pwede naman daw direct system in which water daw is instantly turned into steam by the heat reflected by mirrors in solar thermal system or CSP. So, bakit daw kailangan pa ng HTF? So, ito yung sagot dyan. These working fluids have high heat capacity. It can maintain a high level of hotness in a long period of time. So daw mga heat transfer fluid ay merong high heat capacity. Then, it can maintain a high level of hotness in a long period of time. That is why in concentrated solar power rather, large volume of HTF is heated to an elevated temp during daytime where the sunlight intensity is at its peak. So, Then it is being stored in a tight vessel. It acts as a reserve power that can be used during cloudy days when the sun's intensity is at its lowest or during high time where there is totally no presence of sunlight. So bakit nga ba mas preferable yung heat transfer fluid kaysa sa direct system na ganon? So, ito yung sagot. Paano nagagana yung solar thermal power plant mo kung during gabi or cloudy or umuulan? Paano na siya gagana? Paano siya magpa-function? Siyempre, hindi na siya gagana kung direct system. So, using HTF, so sabi dito, large volume of HTF is heated to an elevated temperature during daytime where the sunlight intensity is at its peak. So, yung large volume ng heat transfer fluid is hinihit niya na during sa pinakamainit yung sinag ng araw. Then, it is being stored in a tight vessel. So, hinihit niya na yung large volume of HTF, then ini-stored niya yung iba sa vessel. Para saan yun, guys? So, ini-stored yun during the sun is at its peak. Then, magagamit yun during cloudy day, rainy, during gabi. So, to keep your solar thermal power plant to function. So, yun, para doon yung HTF, guys. So, heat transfer fluid. The heat transfer fluid used in CSP. So, air. So, pag air kasing ginamit, wala kang reserve dyan sa water. So, molten salt, glycerol-based synthetic oils, yan yung madalas gamitin sa solar thermal power plant. So, depende na lang sa setup ng solar thermal power plant na gagawin nyo. Heat transfer fluid. The following characteristics are being considered on what type of HTF is to be used in solar thermal power plant. So, syempre, ang kino-consider dyan is yung operating temperature, then yung life cycle. So, kung yung heat transfer fluid mo is kaya lang mag-last ng 1 year, so, magastos. Then, yung heat transfer capability. So, dapat yung heat transfer capability niya, ito yung capability niya to transfer heat to water. Heat storage aspect. Ano yung heat storage aspect? So, yung heat storage aspect is kung gaano katagal kayang store ng HTF ng heat. So, overall safety. So, kino-consider din yan. Kasi nga, yung ibang HTF is harmful sa tao. Then, yung cost. Syempre, yung cost. One thing to consider din. So, base sa pag-aaral ng UASA in 2017, so the use of molten salt in parabolic truth system can heat the heat transfer fluid HTF to 500 50 degrees Celsius has a better performance than a synthetic oil which can hit the HTF to only 400 degrees Celsius less. So, base nga daw sa pag-aaral ng USA in 2017, yung molten salt daw is nagamit sa parabolic throat system is can be heated as 500 degrees Celsius. So, mas malaki yung na-i-stack niyang heat kaysa sa synthetic oil HTF na only 400 degrees Celsius or less lang yung na-i-stack na heat. So, kung yung molten salt na yung gagamitin natin sa parabolic throat system is na kayang mag-take na 500 degrees Celsius. So, mas mapapatagal yung init niya bago mawala. So, solar tower. So, sabi ko nga kanina, pare-parehas lang yung solar thermal power plant. Ang pinagkakaiba lang nila is yung setup ng pagkuha ng energy from the sun. The setup in this solar tower is meron siyang maraming mirror. Then yung maraming mirror na yon is nakapokus yun. Kunyari, nakapokus yun or ide-direct nun yung heat ng araw sa receiver or sa isang spot lang. So, basahin natin. The setup includes an array of large number computer-controlled sun tracking mirrors known as heliostat. Sunlight can be concentrated as much as 1,500 times its normal intensity. These mirrors move in a dual axis and are located at the ground level, which collect energy from the sun, then reflects it towards a receiver, which contain HTF located at the top of the tower. So, yun nga. So, yung setup nito is marami siyang mirror. Marami siyang mirror na nagtatrack ng araw. Then, yung mirror na yun, nire-reflect niya yung heat energy or yung araw sa isang receiver wherein lahat nung mirror na yun is nakatutok dun or dun nire-reflect yung heat ng araw sa receiver na yun. Sabi dito, sunlight can be concentrated as much as 1,500 times its normal intensity. So para siyang ito guys, parang magnifying glass wherein yung sinag ng araw na iano mo sa magnifying glass, kung alam niyo yung magnifying glass. So, pag tinutok niyo siya sa araw, is lalabas sa other side niya is isang lang, or ipopokus niya yung heat sa isang spot lang. So, ganun yung mga nito, yung mga mirrors nito sa heliostat. Ipopokus lang. Marami siyang mirror na nakapokus lang sa isang receiver. Wherein, that receiver is merong heat transfer fluid. The HTF is being heated at around 600 degrees Celsius. So, yung HTF daw is being heated at 600 degrees Celsius. And just like in the parabolic throat, this HTF runs through pipe. It goes to a set of heat exchanger. Then, it transfers heat to the water, thereby generating high-pressure superheated steam, which is being used to turn a steam turbine. So, almost the same lang. So, ang pinagkaiba lang nila ng is paano sila kukuha ng heat or paano yung setup nila sa pagkuha ng heat energy. So, ito yung example ng solar power tower. So, makikita natin dito na maraming mirror ito yung heliostat. So, dito, maraming mirror. So, ang nangyari dyan, yung heat energy ng araw is, lahat ng mirror niyan, nakapokus lang sa receiver. Wherein that receiver is in a tower, on the top of the tower, na merong heat transfer fluid. So, yung heat transfer fluid na yun is can take the heat of 600 degrees Celsius. So, yung HTF na yun runs through pipe again, then go to hot salt tank. So, ano yung hot salt tank na ito? Ito yung tight vessel, parang reservoir din. So, dyan magsasave na siya ng So, hindi lahat ng heat transfer fluid is dire-diretso lang. So, yung iba napupunta sa hot salt, or ito yung parang reservoir. So, sabi nga sa parabolic flow kanina, large volume of HTF is being heated. Then, large volume of HTF is being heated during the sun intensity is at its peak. So, sabi doon, large volume of the HTF. Then the other goes to the reservoir. So, yung reservoir nga na yun is hot salt tank. So, hindi lahat ng heat transfer fluid is nagdediretso. Yung iba na i-stop para gawing reserve. Then, it goes again to the heat exchanger. Then, go to the power turbine, generating solar energy, or generating electricity rather. Then, yun lang, heat rejection. So, dito yung parang yung heat rejection nito, dito yung nagko-condense na siya ng superheated steam, kino-condense niya yung matter, or what is condensation. So, condensation is yung liquid is yung gas, tuturn mo siya sa liquid. So, ganon. Then again, the condensed water will go back to the heat exchanger, then goes to the cold salt tank, then lang. So, paulit-ulit lang siya cycle. So, ito yung actual picture ng solar power plant. So, wherein napakaraming mirror na nag-gain ng solar energy, tapos dinedirect niya yun, or nag-gain ng init sa araw, then dinedirect niya yun dito sa tower, sa taas ng tower. So, ito pa another, as we can see dito, heliostat field reflect the heat of the sun to a receiver, then the heat transfer fluid being heated will run to the pipes, then go to the thermal storage and the heat exchanger. Then in the heat exchanger, the heat of the HTF is being transferred to the water, making super hot steam. Then that steam go to the turbine, then producing electricity. Then again, the heat or super heated steam being condensed, then goes back to the heat exchanger. So, ganun lang siya, guys. So, linear Fresnel reflector, general description. The design of this type is combination of parabolic rod and solar tower. This use flat mirrors instead of parabolic mirrors used in parabolic rod. These flat mirrors move in one axis only, unlike solar tower and parabolic dish, which move in two It adapts the working of solar tower, where the mirrors on the ground collects light from the sun and reflect it towards a fixed receiver located above. Previously, sun generates steam directly without the use of extinguishers, which are now obsolete. LFR nowadays also uses HIF for generating steam. The classic LFR or linear Fresnel reflector has only one linear receiver, one on a single linear tower to increase optical and ground use efficiency. The improved design, called compact linear Fresnel reflector or CLFR, use multiple receiver for each set of mirrors so that the adjacent mirrors have different inclination in order to target different receivers. So, dito sa linear Fresnel reflector, ang gamit dito is flat mirror. Flat mirror. The heat of the sun or the light, the light will hit the mirror. The mirror directed the light to the tube. Or pag di sumakto yung ano ng reflect ng mirror, is meron tayong secondary reflector wherein the secondary reflector dinedirect niya yung mga hindi tumamang sinag ng araw sa tube. So, ganun lang siya. Then, same process, the heat transfer fluid in the tube being heated will goes again to the heat exchanger. Then, in the heat exchanger, producing hot steam, super hot steam. Then, that super hot steam goes to the turbine. Then, the turbine produces electricity. Then again, the superheated steam will be condensed, then goes back to the heat exchanger.
Okay, before start my discussion, I introduce myself. So my name is Joshua F. Di Fiesta. So linear Fresnel reflector. So general description. So flat mirrors are used which are cheaper. So gumamit dito ng mas mura na gamitan. So one big disadvantage with this design is the shading effect of adjustment mirror. So which can be encountered only by utilizing more ground space, which increase cost. So very high temperatures are not produced as compared to a parabolic through or a solar tower, and therefore the efficiency is less. So ito yung diagram ng linear Fresnel reflector. So for the solar field, so meron siyang observer and the linear Fresnel reflector. Then the thermal energy storage, so yung observer, meron siyang hot salt tank. Then yung linear Fresnel reflector, nadaan siya sa cold salt tank. Then yung power block, pagkatapos ng hot salt tank, diretso sa may steam generator, then papasok sa turbine. So yan, turbine, then ikot, pasok condenser, and then pump. So yun yung linear Fresnel reflector diagram. So ito yung linear Fresnel reflector. So yun yung ilaw ay yung sikat ng sinag ng araw kukon sa mirror, then yung mirror magre-reflect siya sa may linear Fresnel reflector. Then ayan yung natawag nating linear Fresnel. Then meron din compact linear Fresnel reflector. Dito dalawa na yung linear observer. Then yung the linear tracking reflector. So ayan, nakita natin sa diagram. Next, ito yung compact Fresnel reflector. So yung dalawa na yun yung tinatawag ng linear observer, then the linear tracking reflector. The next is parabolic dish. So yung parabolic dish description and operating principle. So this consists of set of flat mirrors. Flat mirrors combined to form large parabolic dish that is attached to a motor sensor which track the movement of the sun in dual axis. The collected energy from the sun is being concentrated with the PCU located at the focal point of the dish. So the PCU consists mainly of thermal receiver and Stirling engine. So the thermal receiver, which is heat exchanger, that transfer its heat to the Stirling engine, causing it to reciprocate. So the reciprocating movement causes the rotation of an electric generator. So these dishes can concentrate sunlight much better than the parabolic trough, and the fluid run through he can reach temperatures upward of 750 degrees Celsius. So because of the limitation of size and the small quantity of fluid, parabolic dish collectors are suitable for small scale power generation up to a few kilowatts. So the Stirling engine. So yung Stirling engine can be hard to understand. So every Stirling engine has sealed cylinder with the one part. So meron siyang hot and the other cold. So the working gas inside the engine, which often are air, helium, or hydrogen, is moved by a mechanism from the hot side to the cold side. So when the gas is on the hot side, it expands and pushes up the piston. So it moves back to cold side, it contracts. So yung parabolic dish, ito yung example ng parabolic dish. So yung bilog na yon, tawag doon is concentrator shell, yung malaking bilog. Then yung box sa taas na yon, ang tawag doon is Stirling engine package. So yun yan. Then yung naka-stand na ganun sa may Stirling engine package, yung tinatawag ng Stirling support structure. Then yung sa baba, yung turntable. Then nakapaikot sa baba na yon, pinakamaliit, yun yung tawag na azimuth drive arc. Then yung box sa baba na yon, yung tawag din yung switch case. And then yung sa baba naman, yung pinakababa, yung pinaka-stand niya, reinforced concrete ring foundation. Then elevation bearing and concretor ring truss and elevation drive arc. Yan nga. Next is, ito yung Stirling engine. So yan. The largest solar thermal power station. So yung pinakamalaking thermal power station is Port Said Solar Power Station. So may capacity 510. Then the country is Morocco, the type parabolic trough and solar tower. Date cost is 2018, area is 2,500. So yung pangalawa is Ivanpah Solar Power Facilities. Meron siyang 392 capacity. Country niya USA, type niya solar tower. Date cost is 2014 and the area is 1,420. Pangatlo is Mojave Solar Project. So meron siyang 280 capacity. Country niya USA, type niya parabolic trough. Date cost 2014, area is 714. The Solana Generating Station, yung pang-apat, 280 capacity. So USA din siya, country parabolic trough, type niya is then yung date cost ginawa siya is 2013 rather. So the area niya is 780. Then yung panglima, the Genesis Solar Energy Project. Meron siyang capacity na 280. So the sa USA din siya sa country. Makikita din the parabolic trough is parabolic trough type. And then the cost niya is 2014. Then yung the area niya is 9,920. Next is Solaben Solar Power Station. Isang 200 capacity. Ang country niya is Spain, parabolic trough. And then the date cost is 2012. The area is 301. Ito yung Parsate Solar Power Station. And the largest solar thermal power station is still under construction. Mohammed bin Rashid Al Maktoum Solar Park Phase 4. So capacity 600 and then 100. And the country niya is Dubai and UAE. Yung type niya parabolic trough and solar tower. So date to top 2022. So that's all. Thank you.